Dear students, welcome to s.mathguru classes. So today we start some problems about partial differential equation, how to form partial differential equation. Last class the rules are given, it was given, and two problems also done. Now we consider the remaining problems. Form the partial differential equation from x minus h whole square y minus k whole square plus z square equal to a square. So we have two methods. One is eliminating arbitrary constant and another is eliminating arbitrary function. Now this is eliminatory arbitrary constant. Now solution is start. So here given x minus h whole square y minus k whole square plus z square equal to a square. This one given. We consider this is number 1. Now we differentiating both sides partially with respect to x. So what we get here, x and y independent variable, z is dependent variable, and this is del x z square del x a square. This one we get. And if we write directly 2x minus a, and this is 0 and this is 2z del x equal to 0, we get this. Now dividing both sides by 2, x minus h z and del x means p, we get this, and this implies x minus h equal to zp, we get this one. This is number 2 we consider. Again we differentiate this one with respect to y partially. Again del y x minus h whole square del y minus k whole square del y z square equal to del y a square. And here we differentiating partially with respect to y, then this is x is constant, this is 0. And if we write directly, this is 2y minus k, 2y minus k into 1 we get. And this is 2z del y, this equal to 0. So dividing both sides by 2, y minus k, z 2 cancel, and this is q we get. This implies y minus k equal to zq. This is number 3 we consider. Now our main target anyhow to remove h and k. These two are arbitrary constant. Anyhow we remove these two. If we remove these two, we get our final answer. Now putting the values of h minus x minus h and y minus k in equation 1. So we write using 1, 2 and 3, we get x minus h value is minus zp whole square, and y minus k, this is minus zq whole square plus z square equal to a square, we get this, and this implies z square p square z square q square z square equal to a square. So z square is common, then p square plus q square plus 1 equal to a square. So this is the required solution. Therefore the required solution is this one. Very easy solution, very interesting also. This next we consider another problem. Form the partial differential equation from ax² plus by² plus z² equal to 1. Now this is our given condition. From this we have to construct a form a partial differential equation. But before solving this, first you have to find how many arbitrary constant given. A and B are arbitrary constant. So anyhow we remove this A and B. After removing A and B, we get our answer, we get a relation, that relation our required solution. So given, what is given? Given that ax square plus by square plus z square equal to 1. We consider this is number 1. So we differentiating partially on both sides with respect to x, we get this one. A is constant, ddx of x square is twice x, this is y, this will be 0, and this is z square means twice z, del x, and right hand side 1 is constant, this is 0, without showing the chain rule. And here 2 is common, here also 2 common, 2 is cancel, ax plus z, and del x means p. This we know, where del z del x equal to p. Now this z taking right hand side, zp, and x a equal to minus zp by x. We get the value of a. Next again we differentiating both sides with respect to y partially. Again we differentiating del y ax square plus del y by square del y z square del y 1, and we differentiate partially with respect to y, and this term will be 0, constant, and b into del y, del y of y square means twice y, and this is 2z del y equal to 0. Dividing both sides by 2, we get by z, these 2 to cancel, del z del y means q, and b equal to minus zq by y. So we get this one. We get the values of a and b, and these two values putting in equation number 1. Putting the values of a and b in equation 1, we get. So what we get, if we putting the values of a and b in equation number 1, we get a means minus zp by x, this is x square. Just putting the value of a means this, and b minus zq by y into y square plus z square equal to 1. So 1x is cancelled, minus zpx minus zqy plus z square equal to 1. Multiplying both sides by minus sign, then we get, if we multiplying by minus sign, then we get zpx plus zqy minus z square equal to minus 1. If we multiplying by minus sign, we get this, and from these two taking z common, then we get px plus qy equal to z square minus 1. This z square taking right hand side, z into px plus qy equal to z square minus 1, and this is our final answer. Very easy solution, just simple differentiation. Consider another interesting problem. Form the partial differential equation from 2z equal to x square by a square plus y square by b square. Now solution: given that 2z equal to x square by a square, y square by b square. This is number 1 we consider. Now differentiating both sides with respect to x, partially we get, so del x 2z del x square by a square del x y square by b square, and this is 2 is constant outside, del z del x, this is 1 by a square constant, a square is denominator, 1 by a square constant outside, 2x x square means 2x, del x of x and twice x, and this is 0. Then 2 cancel on both sides, we get del z del x by a square, and del z del x means p x by a square. So a square taking this side, p taking this side, a square equal to x by p. This is number 2 we consider. Again we differentiating partially with respect to y. Again 2 del y z, 2 is constant, directly taking outside, and 1 by a square is constant, del y x square, 1 by b square is constant, del y square, because x square by a square we can write 1 by a square into x square, we write in this way. So it taking outside because 1 by a square constant, 1 by b square constant. This is 2 del z del y means q. This is 0 because we differentiate partially with respect to y, and 1 by b square, this is 2y. 2 cancel, q equal to y by b square. So b square equal to y by q. This is number 3 we consider. 3. And putting the values of a square and b square in equation number 1. Putting the values of a square and b square in equation 1, we get 2z equal to x square by a square. A square means x by p, and y square by b square. B square means y by q. This is 2z equal to 1 x is cancelled, we get px, 1 y cancel, we get qy. 2z equal to px plus qy, or we can write 2z equal to xp plus yq, and this is our final answer. So dear students, these are very easy, very simple solution. Just anyhow do or die, anyhow what is your target, anyhow remove a and b, because these two are arbitrary constant. By removing a and b we get a relation, this relation is the required solution. So in this equation, just putting a square and b square and replacing the a square b square, then we get a relation. Here a square and b square absent, so this is our final answer. So I hope you are all enjoying with this problem. If you are all enjoying, then please like this video, and if you are new in my channel, then please subscribe my channel. and click the bell icon. Thank you.